Okay. All right, guys, let's chat about area under the curve. Don't worry, there's actually a lot of application in here. How many medical doctors do we have in here, or medical people? Look at this application here about medical. I guess we'll talk about it when we get there. All right, area under the curve. So let's chat. So let's do something simple. Everyone knows what a train is, right? So let's say I have a train that is set on a specific speed. Sorry, guys, I had mineral water and now the burps are coming out. All right. So here we go. Let's say this train is traveling, what's a nice number? 70? So 70 meters per hour, per second. You know what? We're better with miles per hour, right? 70 miles per hour. And let's say this train travels 70 miles per hour for 2 hours. If you travel 70 miles per hour for 2 hours, how many miles do you travel? 140. How'd you do that? Yeah. I want you guys to notice an observation that if I were to find the area of this, I know I'm making it look like a square, but yeah, notice that the area under that curve is 140. Do you guys notice that? So that's correct. You guys were correct. The area is 140 miles. Miles per hour multiplied by hours, and you just get miles. Do you guys see that? All right, so here's the question to you guys. What if I had a variable speed? Would the area under the curve still be miles? Yes. So that's where calculus comes in. All your life, you've just been doing linear stuff. That's how you were able to calculate distance in physics, because all your velocities were linear and all. But now our velocity is going to be variable. And it's not just velocity, guys. It could be consumption. It could be anything, really. And I guess usually I don't do this until the very end. But look, here's an application. I'm going to go right to the last page just so you guys can see how cool this is. Look how cool this is. Do you want to read this, Miss Kyle? If you want to. You don't have to if you don't want to. Okay.
The number of liters of blood your heart pumps in a fixed time interval is called your cardiac output. For a person at rest, the rate might be 5 or 6 liters per minute.
Okay.
During strenuous exercise, the rate might be as high as 30 liters per minute. It might also be altered significantly by disease. How can a physician measure a patient's cardiac output without interrupting the flow of blood? One technique is to inject a dye into a main vein near the heart. The dye is drawn into the right side of the heart and pumped through the lungs and out the left side of the heart into the aorta, where its concentration can be measured every few seconds as the blood flows past. The data in the table and plot shows the response of a healthy resting patient to an interjection of 5.6 milligrams of dye.
Want to continue? Sorry.
I'm a popcorn.
Huh?
Can I have popcorn?
Can you have popcorn?
Yeah, I will.
Okay.
The graph shows dye concentration measured in milligrams of dye per liter of blood as a function in time in seconds. How can we use this graph to obtain the cardiac output measured in liters of blood per second? The trick is to divide the number of mg of dye by the area under the dye concentration curve. You can see why this works if you consider what speed is.
Okay, you can stop there. So guys, what it's pretty much telling you is you can find out how much blood is being pumped by finding the area under this curve, just like it said in that little thing. Isn't that cool? So now you know why. This is not the only reason why medical students have to take calculus, but now you can see how strong calculus is to do everyday life. I think that's so cool. Okay. Whew. You guys ready? Okay, let's see. Don't worry, guys. We're going to go slow. Page 2 is intentionally left blank. You'll see why. A particle starts at x equals 5, so we're just having motion, one-dimensional motion on the x-axis, and moves along the x-axis with velocity given. So here's how my velocity is given. It depends on time. For time t greater than or equal to 0. Using n equals 6 subintervals of equal width, So this is how many rectangles we're going to use. Rectangles. Approximate the total distance traveled between t equals 0 and t equals 3. Use LRAM, MRAM, and RRAM. Once you find the distance traveled, where is the particle at t equals 3? Okay, there's a lot of stuff going on. All right. So what we're gonna do to find the area under this curve, even though this is not a like t squared, that's a quadratic, we're gonna use rectangles. The more rectangles you use, the better your approximate's gonna be. So I guess first let's start off, since we're rookies, what this stands for, LRAM. So LRAM is an acronym, and it stands for Left Rectangular Approximation Method. What do you think MRAM stands for?
Right.
Oh yeah, that actually because I couldn't tell which one I wanted to do, the M or the R, but RRAM stands for right. Yep, Right Rectangular Approximation Method. And then what do you think the M stands for? Yeah, middle or mid. Mid rectangular approximation method. All right, for those of you listening on YouTube, don't be a hater. Chav, my professor said it's Riemann. I guess. Oh, what the heck did I just do there? These are also, there's a mathematician called Riemann. Have you heard of him? This is his method, Riemann. We're going to be doing something called Riemann sums. This is also sometimes called left Riemann approximation method. If you were to do a Google, I would assume that probably the Google will have this one first, and probably the Riemann second, or maybe do the Riemann first, and then should I Google it? See what it says first? I don't know. This is unscripted here. Let's Google and see what it comes out. So what do I Google? What does LRAM mean in math? What does LRAM mean in math? Question mark. And let's see if it says rectangular or approximation. See, it says rectangular. Let's see if there's one that says Riemann. See, left or right Riemann sums. See? So it just depends what article you look at or what book you look at. They're both the same thing, guys. So don't be like, Chop told me wrong. Like, it just depends what book you use. Are we okay, guys? Okay. Any issues right now? All right. So here's what we're gonna do. I'm gonna sketch. Sorry, there's no reason to have this type of color here. Right. All right. There we go. I'm gonna sketch the velocity. And here it is.
Is it like last unit, the diagram's going to be the hardest part?
I don't think you'll see it. I think you'll find it pretty easy, miss.
She'll find it, or we'll all find it?
We'll all find it. You're funny, Miss Cruz.
No, I was being for real.
We'll all find it pretty easy. Here's t equals 3. I don't have any units on this. It didn't tell me units. And it wants me to find the area under the curve, because the area under the curve will tell me how much distance I have traveled. That's what you guys told me up here, right? The area under the velocity curve tells you the distance traveled?
Yeah.
Okay. How many rectangles do they want me to use? So here's how you're going to find your delta x for rectangle. Delta x is going to be your upper minus your lower divided by the number of rectangles. Child, where's that 3 come from? It's the upper x coordinate minus your lower x coordinate. So 3 divided by 6, each rectangle has a width of 1/2. So that means, let me see if I can do it nice. I'm going to put a 1 right here, and I'm going to put a 2 right there. Perfect. That's a 1, that's a 2. Yes, the delta x is just like the width of each rectangle. So each rectangle is going to have a width of 1/2 because I want 6 rectangles. So that's all I did. So I just put the 1 and the 2, and then between 0 and 1, I'm going to have 2 rectangles. So I'm going to put a little stick there, and a little stick there, and a little stick there. I haven't done anything yet, guys. So, Chav, I don't know what you're doing. I'm drawing rectangles. Does everyone know how a rectangle looks? Okay. I'm gonna start off with the leftmost rectangle. I'm gonna do an LRAM. So I'm gonna put LRAM here so you guys don't get confused. LRAM. All right. My first rectangle, I use since I'll go slow. Sorry, I'm thinking there's so many things going through my head right now. See how it starts with the letter L? So you get the leftmost point on the curve on your first interval. So between 0.5, my leftmost point is a 0. So this right here is my first rectangle. Child, that's not a rectangle. You're on the x-axis. Okay, you got me. You got me there. It's not. Okay, I wasn't trying to be funny. Sorry. All right, my second rectangle. That's n equals 1 right there. My second rectangle between 0.5 and 1. I go to 0.5. I put a point on the curve. Go down like this. Go back to that point on the curve, and you're gonna do a horizontal line until you get to 1. And then boom, there's my second rectangle. Do you guys see how I did it? You're using the leftmost point. That's n equals 2. Child, what does n equals stand for? It's just the number of rectangles, the second rectangle. My third yeah, what's up? Is that a what? That's an n.
No, that's an arrow.
That's an arrow for n equals 1. Sorry, miss. The next one. Sorry. Go to 1, put a point on the curve, go straight down, and then go back to the point on the curve at x equals 1, and do a horizontal line until you get to 1.5. And then a 1.5 go down. That's n equals 3 right there. That's your third one. Do you guys see what we're doing? Go to 1.5, point on the curve, straight down, horizontal line. And represents the number of rectangle. That's my third rectangle. That's my fourth rectangle. This is my fifth rectangle. I'm going to 2. They're supposed to be equal delta x's, but my rectangles look like they have different delta x's, but they're all supposed to be the same width, 0.5. And there it is, n equals 6. I guess you can write it in the inside. And that's LRAM. How do I find area of a rectangle? Width times height. That's all I'm going to do over and over again. So let's see. The width of my first rectangle is a half, so I'm going to write area. Area equals 1/2. That's my width. And then the height is dictated by the point on the curve, right? So my height is 0 squared. So 0 on that one. No, it's just area. It's not instantaneous because nothing's changing. It's just area to the curve. But don't worry, we're gonna be doing something with that stuff soon. We're not. That's just for the first rectangle. I'm gonna keep adding. Ask.
No, I was just gonna ask.
What's the area of the second rectangle? 1/2 times 0.5 squared.
How?
This height here is 0.5 because this is 0.5, and this curve is t squared. So the y let me.
To find the y value, the
So
x value already have just squared.
yeah, that point is 0.5 comma 0.5 squared, right? So that's what I'm doing. That's how I get my y value, 0.5 squared. Don't worry, I still got more. Plus, I still got more rectangles. All 6 of them. 1/2 times, what is this y value here? 1 squared. Oh yeah, 1. Yeah, this point here, that's 1 comma 1.
Oh, okay.
That point is dictated by the t squared, right? I guess that's t technically, but whatever. Yeah.
So why do we put the value it's at rather than the length of the base?
The length of the base is a half for all of them, for all the rectangles, right? And all I'm doing is base times height, base times height, base times height. There's 6 rectangles,
And then you're just
and
squaring it. Wait,
I'm squaring the x value because, or the t value because the y value or the t value depends on the height. So the x coordinate, whatever the or t coordinate is, squared.
Oh.
I'm just, you know what I mean? Like,
Because I know how it's implication of the formula.
it's a what?
Implication of the formula.
Yeah, well, the formula is t squared or x. Yeah.
Yeah, so that's how you're getting your y value.
That's
Okay,
it.
I
Yeah.
understand that.
Yeah. There you
Because
go.
if we don't know the y value, so then we just plug in the formula.
Yep.
Okay.
1.5 squared plus plus that plus is this plus 1/2 times 2 squared plus what's my last one here? 2.5 squared.
And this is just approximation.
This is just approximation. Is this an under or an over? Under, because look at all these gaps. Look at all those gaps right there. Do you guys see that? All right, someone take a calculator and do that for me real quick. Oh, that's where calculus comes in. We're not there yet. All right. Is there an easier way to do this? Notice that they all have a half in the front. Can I factor out a half? Yeah, look. Go half and then just parenthesis 0 squared plus 0.5 squared plus 1 squared plus 1.5 squared plus 2 squared plus 2.5 squared.
So the formula used for the area was 1/2.
Base times height. Rectangle. Base times height. Base times height. Base times height. And I did that 6 times.
So then where did the square come from?
Where did the square come from? That's how I get the y value of the rectangle. Or my T rank.
Whenever we're finding
Look, I think you'll see it here. You see this right here, this point in blue? Well, this x coordinate is 2.5.
as long as we yes, I understand we plug it in and then we square it
Yep.
essentially and then we get the y value.
Yep.
But I just don't understand the formula for to find the area.
Oh, this is a rectangle. How do I get area of a rectangle? Yeah, length times width. That's all I'm doing. This delta x was 0.5. That's what we did. This height is whatever 2.5 squared is. So length times width. Width times height. Half times whatever the y value is.
And base times is the same thing as base times height.
Mm-hmm. Base of this, 1.5. Height of that rectangle. You know what I mean?
I still don't know where the y value.
That's the how many rectangles do I have?
5.
No, 6. Well, yeah, I'm supposed to use 6 rectangles, and I'm supposed to use 6 rectangles between 0 and 3. So my delta x has to be half for each one. Yeah, there is 5 technically on this one, but my first rectangle has a height of 0. Do you know what I mean? And see, the delta x is right here. That's where my delta x came from, the width. Upper minus lower divided by how many rectangles I want. They're all equal width. So this right here is a half. From here to here, that's a half. From 1 to 1.5, that's a half. From 1.5 to 2, that's a half. From 2 to 2.5, that's a half. From 2.5 to 3, that's another half. So all the bases are half. And I just got to calculate the height. You know what I mean? Okay. What was this number, guys? Did someone calculate it for me, please? What is it?
6.875.
That sounds correct to me. All right, go to the next page. It's blank on purpose. We're going to do the same thing, except this time we're going to do
The right.
RRAM, rightmost. So,
What was the units?
oh, they don't have any units, but if it did, it would be whatever the units are. Like if it was meters per second times seconds, it would be meters. Well, for now we're rookies, so we're going to do it 3 times. Eventually, you're not going to do it any times, but right now we're rookies, guys. Just like we did derivatives, we have to do limits first. This is what we got to do first. All right, so exaggerate. What curve am I exaggerating? T squared. That's just like a parabola, guys. Like x squared. Exaggerate it. I'm going to call that 3. I'm going to call this 1. I'm going to call this 2. And I'm using RRAM. I already know that the delta x, or the delta t, I guess, I already know that my delta x is half. I'm writing delta, it really is a delta t here, but I'm writing delta x because you guys are familiar with that. Are we still okay, guys? Okay, so here we go. I'm gonna split them like that. All right, I'm using the rightmost point. So now you are gonna have 6 rectangles. The rightmost point between 0 and 0.5. So I have to use the rightmost point. So I have to use it at 0.5. And there's my first rectangle. Do you guys see that? Yeah. This is 0.5. Between 0 and 0.5, I have to use the rightmost point. So you go to the, yes. You have to go to the rightmost point on the curve and then do a horizontal line until you get to the 0. And there's my first rectangle. You guys see that? Between 0.5 and 1, so I'm going to go to 1, x equals 1, line going down, and now go back to the curve at x equals 1, and a horizontal line at 1, and then stop at 0.5. Go and then go down at 0.5 like that. You guys see how we did it? It depends on the curve. Between 1 and 1.5, I'm going to go to what x coordinate? 1.5. And then there it is, guys. I don't know. Is it a 6th grader? Let them be, guys. You're only a kid once. Let them be kids. Oh. Let her. Don't take someone's joy away. Let them be happy. Are we okay right there, guys? 2 to 2.5, go to 2.5. I'm trying to make them where they all look the same width. I did a little better job on this one, but it doesn't look, this one looks kind of skinny to me, but that's fine. And there it is, guys. I really do have 6 rectangles now. How do we feel? N equals 1, N equals 2, N equals 3. You don't have to label that. I'm just doing that just for your purposes. Area. How do I get area of a rectangle? Yeah, length times width, or width times height in this case. 1/2 times 0.5 squared plus 1/2 times 1 squared plus 1/2 times 1.5 squared plus 1/2 times 2 squared plus 1/2 times 2.5 squared. And this one does go all the way to 3. See, my 6th rectangle. So I guess I'll color code it here, or this one's n equals 1, this one's n equals 2. Not color coded, but this one's n equals 3. Those are all the areas of the rectangles individually, and then I'm just going to add them up. Do you guys see what we did?
How will you know, like, you know how we went almost under the line for this one and then kind of went over for this one?
Mm-hmm.
How do you know
when to do which one? They will tell you which one they want. They always tell you which one they want specifically. Give me an RRAM, give me an MRAM, give me an LRAM. Oh, we don't. It depends on the curve. This curve was a quadratic. It's concave up. So on a concave up curve, if you start from the right, it's going to be over. If it were concave down, if you start from the right, well, it's still going to be over. It depends on increasing, decreasing. But we're getting ahead already. If it were decreasing, and you did an RRAM, see? So we're not there yet with is it above or is it an over approximation or under approximation? It depends on whether you're increasing or decreasing. We're still okay? We're okay, guys? All right. What's this area? Did someone figure it out? I guess you can factor out the half. 0.5 squared plus 1 squared plus 1.5 squared plus 2 squared plus... You need a calculator for this, guys. I don't know what that is, but I know it's a number.
We started from the right. We know we're going to include 3, right?
Yes.
So realistically, can we just add 3 squared to the last?
Yes.
So you just add 9.
Well, you still got to add 9 to whatever you had on the inside and multiply by half. Yeah.
See, I would have said 12.
Oh, but it wasn't 12. What do you think we're going to do next? Middle. Yes. RRAM was an over. Say it again. RRAM was an over approximation, guys, because notice that every rectangle is above the curve. Now here we go. Oh man. Okay. What do you think we're going to use for MRAM? The middle. What's the middle between, well, I guess let me do the little 0.5, 1.5, 2.5. Okay. Remember, all my delta x's are still 1/2. Does everyone know how we got that for the width that are all 1/2? Okay. What's the middle between 0 and 0.5? No. 0.25, right? That's what you meant to say? Or that's what you said? 0.25? It's the middle between 0 and 0.5. Go to the middle, then stretch it to the left, horizontal line, stretch it to the right until you get to 0.5, and you should have a little bit above, a little bit below the curve. We still have six rectangles, guys. What's the middle between 0.5 and 1? 0.75. Go to x equals 0.75 on the curve. Go to the left. Go to the right. You should have a little above, a little below. What's the middle between 1 and 1.5? 1.25 on the curve. Go to the left. Go to the right. What's the middle between 1.5 and 2? No, everyone at the same time. 1.75. And carry on. No, I got you guys.
So, like, if you got a question, if it was under over approximation, we could put neither or both.
No, on this one you can't tell. Not yet. For MRAM, you can't tell. For RRAM, can you definitely tell that you're over approximate? Yes. For LRAM, can you definitely tell that you're under approximate? Yes, they will ask you those questions. They will not ask you, like, look at this one here, MRAM. They will not ask you if this is an over approximate or an under approximate because you don't know. Now, do you think this is probably the best approximate from all three of them?
Yeah.
Probably. They probably could ask that. What's an ideal approximate? Probably this one. So here we go. My area for this one, 1/2. They're all still 1/2. My first rectangle is dictated by 0.25. Whatever that is squared. Plus 1/2. The second rectangle is dictated by 0.75. Whatever that is squared. Plus 1/2. My third rectangle is dictated by 1.25. 1/2. 1.75. 1/2. 2.25. 1/2. 2.75. And there it is. That's all 6 rectangles. 1, 2, 3, 4, 5, 6. Yep. You can factor out the half again. And probably do this. 0.25 squared plus 0.75 squared plus 1.25 squared plus 1.75 squared plus 2.25 squared plus 2.75 squared. Does anyone have an answer for that? You got an answer for me, Morales? Oh man, do it real quick, or someone. Yeah.
So is 15, so 55 is the middle of 0 and 1, right? So
Yeah.
Okay.
0.25 is the middle between 0 and 0.5.
But so you're splitting in the middle and you're splitting in the middle again?
What?
So you're splitting like
Well, I have 6 rectangles. So I have 2 rectangles between 0 and 1.
yeah.
So what's the middle between 0 and 0.5? 0.25. What's the middle between 0.5 and 1? 0.75. Right? Because I'm just splitting, because I have 6 rectangles, so I have to put 6 rectangles. So I have a rectangle between 0 and 0.5, and what's the middle between that? 0.25. I have a rectangle between 0.5 and x equals 1, so what's the middle between that? 0.75. Yeah, they told me 6 rectangles right here. N equals 6. If I would have had 3 rectangles, then I would have used 0.5, 1 point, you know what I mean? But I have 6 rectangles, so I got to.
Those 6 rectangles you use in the middle.
Yep. Yes, ma'am. Did someone already do this, guys? I already started, so that's the only reason. But I'm pretty sure I'm going to get what you got, I hope. $8.9375? Yay, look at us. Okay. Let's answer the question. And no yawning. What's the demerit? You're good, miss. All right. So they wanted to know, okay. So answer me this. Answer me this. I found like a riddle. Riddle me this. Okay. Real quick, guys. Price. Real quick. How do I get the best approximation if I increase the number of what? Rectangles. Okay, now answer this question here. If I make the number of rectangles approach infinity for the LRAM, MRAM, and RRAM, will they all converge at the same number? They should. Like, they're going to all center at a value, go to a specific number. If I make the number of rectangles infinite, right? So if I make the number of rectangles infinite for LRAM, like imagine putting a whole bunch of rectangles in there. And I'll show an application where that is the case. Imagine putting a whole bunch of rectangles in there. You're going to make the area better. And if you do the same for all 3 of them, LRAM, MRAM, RRAM, you make the number of rectangles approach infinity, all 3 of them better approach the same number, right? And that's exactly what happens. What do you think the area is of this, by the way? Look, the left RAM is 6.875. The R RAM is 11.375. The middle RAM is 8.9375. Take a guess. What do you think it is? Somewhere around 9. Yeah, somewhere around 9. If you go to the next page, that's exactly what they did. This is for the example 1.
Oh, so it's almost like finding the limit from the left to the right.
See, it's the whole limit thing. Look, if I have 6 rectangles, did we get 6.875? Did we get 11.375 for RRAM? Did we get 8.9375? Look what happens if I have 12 rectangles. 7.9, 8.98, 10.1. LRAM, MRAM, RRAM, respectively. Look what happens at 24. Look what happens at 48. Look what happens at 100. Look what happens at 1,000 rectangles. LRAM, 8.9865. MRAM, 8.99999. RRAM, 9.0135. All 3 of them are converging at what number? 9. Do you guys see what's happening? So now we know. So let's go back and answer the question. So how do we answer it? Do I got any room anywhere? I'll answer it. Okay, I have room right here in this little corner. I don't know if you guys have room there. It says to find the total distance traveled. Total distance traveled is what? 9 units. I don't know what the units are. Okay, that's the first question. Now let's answer the second question. Where is the particle at t equals 3? The particle at t equals 3 is at x equals, okay, time out and let's talk about this. Where was I initially? Bless you square. Where was this initially? 5. How much have I traveled? No, that's the time. How much have I traveled? What's the first bullet say? 9 units. So if I've traveled 9 units, where's my location now? Yep, you got it. The particle at t equals 3 is at x equals 14. And I'll put in parentheses how we got it. Parentheses. 5 plus 9. And then for you physics people, that 5 is initial value. And then that 9 is the distance. Distance. Do you guys like the burnt orange? I can change the color. I don't know if we have any longhorns in here. Okay, I'll put maroon next time. Okay. Yes, the particle, Miss Houston, initially started at 5. And then how many units did I move? 9. So imagine you're on a ruler, and that ruler, you're in position, a big giant ruler, and then you move 9 units to the right.
Okay. Yeah. Okay.
You know what I mean?
Yes.
By the way, you're going to be doing the same stuff when you get to your university. I'm not trying to be one of those adults that tells you what to do, miss. I'm just letting you know that you're going to see it again. All right, how are we feeling, guys? I think we're good. Let's do some more examples, and then we'll call it a day. We just got 2. We just got 2 examples, and then we got a little handout. And don't worry, the handout's not due till tomorrow. It's over the same stuff. And relax. We're good. True or false? Ready? Guys, we're almost done. Oh, propels us? Okay. Yeah, you're right. I think it's coming from that horror movie that I saw. Okay. All right. If an MRAM sum with n equals 4, sorry for that, and I'm recording this. I'll just leave it. We have fun here. If an MRAM sum with n equals 4 rectangles of equal width is used to approximate the area enclosed between the x-axis and the graph of 4x minus x squared, the approximation is, okay. You can be honest. I don't judge. Without a calculator, do you guys think you guys will be able to do that?
Yes.
I think you would. It's a quadratic. Check it out. You could factor out an x, and then I'm going to have 4 minus x. So that means if I set this equal to 0, I have a 0 at 0 and a 0 at 4. Unless I made a mistake. So because it's a quadratic, I'm going to assume this is symmetric at x equals 2. I could be wrong, but I'm pretty confident that this is correct. 0, and I'm going to say this is 4. And I'm pretty sure it looks like this. How many rectangles do they want? 4. So my delta x for each rectangle is 1. I'll show you how we get the delta x, guys. Delta x just means the width of each rectangle. 4 minus 0 divided by 4. So that 4 is your n. How many rectangles? This is upper. And this is lower. Your upper x value, the lower x value. You're going to see that later on when we start doing technical stuff. So that's why I'm writing it. I know you can do it without even. I know you can do that without even writing anything, but I'm just putting it in there. All right, what RAM do they want me to use? L, M, or R? M. So I'm going to go to the middle. There's my first rectangle. Do you see how I got my first rectangle, guys? Okay.
No, give us a calculator, right?
If you have a lot of rectangles, yes. But if you have a small amount of rectangles, no. We'll do some free response questions where you'll choose. Rectangle 2 and rectangle 3 should have the same height, guys. But if you didn't draw it perfect, it won't look like the same height. So the middle between 1 and 2 is 1.5, and I went to 1.5 on the curve, and I put a point. The middle between 2 and 3 is at 2.5. So I go to 2.5, and it should look like that. So rectangle 2 and 3 should look the same, like the same height. And then, so rectangle 1 and 4 should probably be the same height because it's symmetric at x equals 2. And that's a demerit. I'm kidding. I did the bright idea of, I got home like at 9 p.m. when I left here. And I was so tired. And I'm like, I got a lot of work to do because I had to turn in the decathlon papers. And I'm like, okay, I'm going to take a nap and then I'm going to go full throttle. Well, instead of a 1 hour nap, I fell asleep. I slept like 3 or 4 hours. I don't know. I woke up at 2. And at 2 a.m. I started working. So I've been up since 2 a.m. That's why I said almost all-nighter. Not quite, because I did get some sleep. But it wasn't good sleep because I kept thinking of stuff. Anyways, sorry, miss. All right. Sorry that I went on a tangent there, guys. I went on a tangent. Okay. Here we go. I just want the area. How do I get area of those rectangles? Yeah, width times height. That's all we're doing. The width of each one is 1. So 1 times and then the height. The height of this oh yeah, you're gonna need a calculator. So the height of that one, let's see, 4 times 0.5. Is that 0.5, right? Minus 0.5 squared. Close it. Plus, do you guys know what we're doing? Oh, how do I get the area of this first rectangle? Width times height. That height is dictated by whatever that x value is. See? I'm just putting it in here. So that's my y value.
Yes. Oh.
So plus 1 times, what's the next x value? 1.5. Oh, you're good. The 1 is the delta x, the width of each rectangle.
Can you get rid of it?
Yeah, you can get rid of it. I'm just putting it in there for technicality reasons. You know what I mean? I'll show you how to do it fast in a little bit. Oh, that's it, right? Oh, no. 3.5. 1, 2, 3, 4. There's 4 rectangles, huh?
So the whole should add it instead of subtract.
Oh, yeah.
So the whole
Dummy.
reason for plugging the values is just so that we can get the y whenever you do like head width.
Yeah.
Okay.
You're just getting your y value. You know what I mean? That was a question, right?
Yes.
You guys want to see an easy way instead of doing it all this? How many of you guys are programmers? Have already done computer science? Okay, so look, this is all programming. This is where computer science comes in. So you're probably going to be a boss at this. Look how simple this could have done. Computer science. Go to y equals, type in the equation. What was the equation, guys? 4x what? 4x minus x squared. Look at this. And I could just say, okay, well, Chav, there it is. There's my equation. You don't have to do it over and over again. That's cumbersome. Just go like this. 1 times alpha trace y1 evaluated at 0.5. That's my first rectangle. I don't have to do any squaring or anything because that is my length times width. Plus, and I just keep going. And then I'm gonna drop the 1. Is that okay with you guys? Because 1 time, okay. Put in the other y values. What is the other one? 1.5? Plus alpha trace y1 at what? 2.5. And then finally the last one is at, and this is why programming is so amazing, guys, because anything that is repetitive in nature, you can just make the machine do it. Is there an 11 in there?
Yes.
There it is. Yeah, I feel like we did something wrong because, not with this question, with AI, because I don't want AI to do my math and poems and art. I want AI to do my dishes and do my tub and clean my, you know what I mean? And clean my clothes. That's what I want AI to do. But instead, now AI is doing the math for us and the art and the music. Like I was, okay, I was messing with it, and it makes songs. It can make a song like whatever you want with its own lyrics and background and country. Like I want an artist to do that. I don't want AI to do that. Why are you judging me, Miss Kyle?
Are you saying a mathematician
Math
has
is
an
an
art?
art. Math is an art.
I just feel like AI is taking away
This is art.
creativity, human creativity.
You know that there is an AI robot.
Well, you don't get your.
There's a whole bunch of them. Which one? Watson?
Yeah, like, I don't know which one it is, but like if you do your dishes and stuff.
Oh, there is? Okay, that's what I want.
My dishes are like really
Is
expensive.
it called?
Oh, well, that-
But
no, but like place them like in the right place. A dishwasher, like I still have
Are
to.
you really lazy? You don't want to put your dishes in.
Well, I don't. Well, Miss, I don't have a dishwasher, Miss.
I don't like using my dishwasher.
I don't have a
4
dishwasher.
hours.
4 hours.
Okay,
4 hours.
here we go, guys. Sorry. One more. Here we go. An LRAM. One more, guys. This is the last one. An LRAM sum with 4 equal subdivisions used to approximate the area under the sine curve from 0 to pi. What is the approximation? Do you guys still remember pre-cal? Sine. I'm gonna say that's a 1. That might be too high. Let's see. I'm exaggerating it. This is sine. It's supposed to be sine x, but I didn't exaggerate it. Super awesome. Way over here, that has to be pi, because sine of pi is 0. right smack in the middle is pi over 2. How many rectangles do they want? 4. So how do you find your delta x? Pi minus 0 divided by 4. So pi over 4 is my delta x. Do you guys see how I got that? You guys probably would have figured it out either way without having to do that. So here's pi. So I'm going to go boop and boop. Do they want me to use LRAM, MRAM, or RRAM? LRAM. This is pi over 4. Pi over 4 plus pi over 4 is pi over 2. And pi over 2 plus pi over 4 is 3 pi over 4. So just a little bit of pre-cal. Here's my first rectangle, guys. You don't have one. It's on the x-axis. Cool or not cool? Here's your second rectangle. We're still okay? Here's your third rectangle. Here's your fourth rectangle. Oh. I didn't do it perfect. I think rectangle 2 and rectangle 4 should have the same height, but that's fine. How do I find area of a rectangle? Length times width, or width times. I'm gonna start saying width times height. Is that okay with you guys? Because this is width and this is height. Okay. The width of each rectangle is how much? Okay. Pi over 4. And then what is sine of 0? Because sine of 0 is, that will tell me my y value, right? 0. Plus, you know what? Let me do it the way I want to do it. I'm just doing width times height. Pi over 4. Height. What is sine of pi over 4? Square root of 2 over 2 plus pi over 4. What is sine of pi over 2? 1 plus pi over 4. Does everyone understand what I'm doing, guys? I'm just doing width times height, right? What is sine of 3 pi over 4? There it is. Let's look for that answer. They all have a pi over 4 in common, so can I factor out a pi over 4? Where do you guys see it? Square root of 2 over 2, 1, square root of 2 over 2. Number, what letter? C. How do we feel? Yeah, that's all we're gonna do. Can you pass these out for me, Miss Houston, please? You guys did a good job today, guys. Sorry that we went off on lots of tangents today, but